In this problem, we're asked to evaluate the integral of sine cubed of x times cosine to the power 4 of x. And this is an integral that we're going to be able to compute by using the method of substitution. And in fact, anytime you have an integral of this form where one of the powers is odd, or both of the powers are odd, then you'll be able to use this method. So what we're going to do is we're going to first look at the sine cubed of x factor, and we're going to split it up. We're going to split it up into sine squared of x times sine of x. The reason we're doing that is because later we're going to let u be cosine of x, and then we'll need a factor of sine of x when we write du in our expression. However, right now we have both sines and cosines, and we're going to want the integrand to be entirely in terms of cosine when we do our method of substitution. So we need to use a trig identity to replace the sine squared with something involving cosine. The trig identity that we will use is the most basic one, cosine squared plus sine squared equals 1, which is just saying that the radius of the unit circle is 1. So we'll rearrange this, solve for sine squared. That's easy enough, we just subtract cosine squared to the other side. And so now we're going to be able to replace this sine squared with 1 minus cosine squared. We'll do that in the next step. So all that's changed is the sine squared got replaced with our new expression. Now we're going to want to let u be cosine of x. And when we use the method of substitution, as always, we need to figure out the relationship between du and dx as well. So we take the derivative of cosine. It is negative sine. And since the du is equal to negative sine of x dx, but here I have a positive sine of x dx, I'm going to multiply both sides of this by negative 1. And so du, or negative du, is equal to sine of x dx. We can now replace the cosines with u's, and this expression, this sine of x dx, with negative du. So we go ahead and we make these substitutions. Cosine squared turned into u squared, cosine to the 4 turned into u to 4, and this expression turned into negative du. Next, I'm just going to simplify a bit before I integrate. I'm going to distribute the factor of negative and the u4 into the expression to the left of it. After I do that, I'll have a positive u to the 6 minus a u to the 4. Now we have it in a format where we can just use our basic rules of integration. This integrates the u to the 7 over 7 minus u to the 5 over 5. And the last thing that we need to do, as usual, with a method of substitution problem, is go back to our original variables. So u was cosine of x. Now it's time to replace these u's with cosine of x. That leads to this last expression, which is indeed our final answer. In this problem, the function that had the odd power was sine, and we let u be cosine. If the function that had the odd power was cosine, then we would have used the same approach, but u would have been sine of x. But the procedure would be very similar.